Hello and welcome to this Mobile Touch Plus beginning iOS development screencast. I am Alex Ackerman, and in this screencast we are going to be looking at Windows views and view controllers, looking in depth at exactly what they are and how they work inside an application. So to begin with, we are going to go through a short keynote and then I'll go into just a short practical application, just showing how Windows work inside an application as well as creating a view and view controller. Okay, so our first slide is on Windows, or the UI window class. UI windows are a container for views in an application. They are actually inherited from a UI view, so they are a UI view. However, they do inherit some special features that make them UI windows. They're responsible for managing the device orientation as well as the orientation animation you see on a device when you rotate it. They also manage touch events with child objects. In iOS applications, there are three layers of windows. The first and frontmost layer is the status bar window, which shows the status bar at the top with the reception information of the cellular device, the clock and the battery meter, as well as some other icons around GPS and other features like that. Then the middle layer is the alert view, where your UI alert view windows will be displayed above the application window. And of course the application window is where your main application resides. So this shows you that on an application how the windows are stacked and layered so that when a UI alert view takes up the space on top of the window, that you won't be able to get touch events to the windows behind it. So that's how it effectively blocks touch events from proliferating through to windows behind one another. Apart from that, that's all that UI windows are. They are just basically view objects that have some special properties just to make them windows on the application. You can have more UI windows if you are using an application with an external display such as an iPad. Now looking at views, or the UI view class, this is the base object that's responsible for drawing objects onto the device's screen. As you saw, the UI window inherits from the UI view. That's because to display anything on a screen in a typical UI kit application, you have to use a UI view. UI views are stackable and they can have many subviews. They can also be layered in particular orders. You can send layers from front to back dynamically and at any time. They have a variety of basic properties which include their dimensions, which has two types of dimensions, frames and bounds. As you can see, that little animation on the side, bounds is where the content resides, and a frame can be the outer border around an object where the content is not shown. Then it also has opacity or alpha settings, as well as if the UI view is opaque or not. Opaque meaning whether the background shows through from other layers behind it. And it also has auto resizing options, so when that UI window decides to change its orientation, the device knows how to stretch and reposition the object. There's also many more properties available on the UI view class. It's worth having a look at the Apple documentation on the UI view class so you know what's there to begin with whenever you extend a UI view. And then last but not least, UI view controllers. These are very important in an application as they act as the management between a UI view and a model in an application. What I mean by model is it's particularly referred to as the data side of your application. So if you're running core data, or if you've got a particular data method where you're storing something on the device, you'll have that as a model. Your UI view controller will sit in the middle and then send data to the UI view when it's requested. The SDK has many controllers built in. These have a range of functionality. You would have seen them: the UI navigation bar, tab bar, table view, and image picker. These will have all their particular properties already assigned to them. They have actions and events as well as animations associated with those actions. So when you use the tab bar, it swaps between two UI views. When you use a navigation controller and you want to go back and forth between two views, it has that animation already pre-built into the view controller. which is an extension of the UI view controller class. And as I was saying before, the view controllers follow the model view controller design paradigm. This is common in most application development these days, where you will separate the functional code from a view and keep all the actions and event-based logic for an application in a controller and not in a model. Your model is, as I've said, your data source. It's where your data is collected from, and then your view controller decides how it responds to actions resulted from the view when a user taps on a button, or any other events that the user can do. So with the theory over, it's now time to build a demonstration application to show how windows, views, and view controllers are used within applications. So I'm just going to create a new Xcode project, a new window-based application. I want it as clean and as fresh as possible just for this demonstration. iPhone as usual, and I'm just going to call it Lesson 5 Demo. Okay, with this base application, what I'm going to do is I'm going to make it so we have a view controller and a view inside that with a button inside, so when we push the button, it'll display a UI alert view, and at that time when we display the UI alert view, I'll pop open the console so we can actually get a readout of what windows are actually present, so you can see that the application has many windows showing at the one time. So to do this, I'm just going to start off by creating our view controller. And in this view controller, I want it to respond to a button press, so I'm just going to put in an IB action for button pressed. And of course, with all IB actions, they have one attribute, and it's commonly known as sender. It's just the ID of the object that sent the request. Okay, so I'm now going to implement that in the M file. So just down here, IB action button pressed ID sender. And I'll come back to that in just a moment. What we'll be doing in there is popping open a UI alert view, as well as I'll be NS logging out some information, which we'll have a look at in just a minute. So save that, and I'm now going to go to the view responsible for that particular view controller, the zip file. And in this zip file, I just want to create a simple button. And I'm just going to bring over a little resource I have here, just a little image to make the button just a little bit more prettier. There we go, and now to link that button press up with the file's owner. If you want to know more about what I'm doing here in relation to IB actions and as well as IB outlets, check out the interface builder fundamental screencast I did a couple weeks ago. So I'm going to link that back to the touchdown event. So when the button is pressed, the touchdown event will fire and it will call that action. So that's about it for that bit, actually, quite quick and simple. Now I just need to link the view controller up with the main window. So what I'm going to do here is I actually need to go to the application delegate in the header file, and I need to create a reference to a UI view controller instance. And I'm just going to put that as a property as well as being an IB outlet. Oops. Okay, and just the usual synthesizing and as well as the deallocating in the dealloc method. Oh, and there's one final thing to do here. I need to add the view controller to the window. So self.window, add subview and view controller dot view. Okay, with that all done, the view will now display when the application is launched. I just need to put the view controller inside the main window file here. So I'm going to go up, select a view controller, drag it over and link it up. So I need to set its class to demo view controller and the nib to demo view controller as well. So we now have in our main window.zip here our demo view controller, and here's the app delegate class. I need to control click on that, bring up our little outlets and actions window here, and I'm going to link up view controller with the view controller we just created. Okay, so the next thing I'm going to do is I'm going to implement this button press method. I'm going to launch a UI alert view, and that's just done by initializing and allocating a new alert view. Oops. And it has this handy initialization method where you can set the title, then I can set the message, and a delegate associated with this particular alert view. So if you want to know when the button is pressed and fire an event on that, then you would add your delegate in here. For now, I don't want a delegate, I just want it to show, and then the cancel button, which is the default. It has the default of one button, which is the cancel or close button for the particular alert view, and that's the title for that there. And I'm just going to set the other button titles to nil. I don't need any other buttons, just one for now. And then once the alert view is created, we can then show it. So alert show, and then alert release. We don't need an instance of it anymore. Now I said that I was going to implement an NS login here. What I'm going to do is I'm going to output all the current windows that the application has currently allocated to the screen. Okay, so now I put that in, it just basically gets the current application and then displays the Windows property for the application. That will output as a nice array, and we'll be able to see that in our console. And the last thing we're going to do in this view controller is we're going to allow device rotation. And with that done, what I want to do next is I want to make sure the button will automatically auto-size to the correct screen orientation. So for that, I need to go to the size panel here. I want to say that its width is flexible and it's fixed to the left and right sides as well as the top. So it will stay in the same vertical position. For that, I might just move it up just a little bit. Okay, so now it's time to run our application. I'm just going to build and run here. I need to open up the console as well, so I'll open that up. And so we have our nice little application here. It rotates, it has a view controller, has our view, and it has the button inside that view. So when I click on the button, we will get our UI alert view, which we specified in the code, as well as the output of the current stack of windows in our application. You'll see that there's now two. We have a UI window, which is our main application window, and then we have an alert overlay window, which is the UI alert views window. So this window sits on top of our application, which stops any clicks or taps back to that previous window. Then once we click OK, that window will be released and we'll be able to click back in our application. If we do any rotations, you'll see that both windows respond to rotations as they both get messages sent from the device saying, I rotated. So that's about it, explaining what views and windows and view controllers are. View controllers are, from the MVC design paradigm, they do control the actions, events, and code behind the particular views that you're displaying. The views are just visual representations of data or input areas for users to input data, or buttons that allow users to interact back to the application. Windows are a collection of views, typically windows in an actual application on the desktop environment are what you see here. These are all separate windows here. In the portable device spectrum, windows are for the full size of the device. So you can only have one window in an application at a time, unless you want to do anything fancy around the status bar at the top, which some applications have used to show custom icons when the application is updating. And of course, there's UI views, which are the essential base to any interface element you want to put on the device. Very extendable and very easy to use. So that's about it for this screencast talking about Windows views and view controllers. If you have any other questions relating in this area, please drop a comment on Mobile Tuts. And I hope you join us next time, where Mark Hammonds will be talking about artful debugging. Thanks for watching.